Hey, it's a quick video on writing reactions for synthesis, combustion, decomposition, and single replacement reactions. Okay, just a pretty brief introduction to this. So the pack you're getting, the front of it has different types of reactions. Okay, so give some examples like synthesis. Remember, synthesis is two things coming together and to make one. Okay, so it's got each of those on the front of it, so you can look at those for examples. I'm going to do the second page of it and give you one example of each one. So first part over here, sorry about the glare that's in the middle of that. First thing is knowing the 7 diatomic elements. Okay, so if you had Mr. Ruby, he does have no fear of ice cold beer. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, those 7 elements are diatomic. When they're by themselves, they always occur in pairs. Not when they're in compounds necessarily, depends on the charges, but when they're by themselves. That means other elements like potassium or calcium or argon, or whatever it is, aluminum. Okay, those things will not be diatomic. When they're by themselves, they will not have a little 2 with them for a subscript. Okay, only those elements. So I will do one reaction from each section. So synthesis reaction, sodium and iodine are reacting. So that means sodium plus iodine are reacting. 2 separate things. Sodium's a metal, okay, reacting with iodine, which is non-metal. Iodine is one of the diatomic elements, so it needs a 2 with it. Sodium is not. Okay, so synthesis means they come together. So there's my arrow, and they form a compound of sodium iodide. Sorry, you can't see the iodine very well in there. Let me move that over a little bit. So we'll say that they form sodium iodide. Okay, that 2 does not necessarily transfer. Now you got to look up charges or valence electrons. This is the +1 charge, this is the -1, so just NaI is your formula. Again, completely new substance over here from these two. They were separate here, they formed a compound. That compound is way different than these 2 things individually. To balance it, I need a 2 out in front of that, so I need 2 molecules there and 2 atoms of sodium there. Again, this means these 2 are bonded together. This means there's 2 separate atoms of sodium. Synthesis reaction, making a bond between those 2 things. Next one will be a combustion reaction. So I'm going to do number 3 here, the combustion of this. This is called hydrocarbon combustion. You may want to write that down. Hydrocarbon combustion. This one up here is not hydrocarbon combustion, but hydrocarbon combustion means you have a hydrocarbon. There are millions of those compounds. So we have C8, H18. That's a hydrocarbon. Actually, I'm going to move that further left so I don't run into that glare again. Combustion means, remember, it's burning, so combining with oxygen, which is diatomic. For all hydrocarbon combustion, it's always going to produce the same 2 things. It'll always be CO2 and H2O. Hard to see again. CO2, H2O. So every time we burn a hydrocarbon, it's carbon dioxide and water. When you burn zinc, it is not hydrocarbon. It's not a hydrocarbon. So you do not get carbon dioxide and water. A little trick here. If this number is divisible by 4, no number out in front of here. If it's not divisible by 4, double this. So we need to double this one. Makes a 2 there. 2 times 8 is 16 carbons, so we're going to put a 16 here. 2 times 18 is 36 hydrogens, so we need an 18 there. Count your oxygens. There's 32 oxygens right here. 18 oxygens right there. Add those up, that's a total of 50 oxygens that are being produced. So we need 25 times 2 gives me 50 oxygens on that side of the reaction. Again, hydrocarbon combustion. Next one I will do is a decomposition. I'm going to do the decomposition of water. So you decompose water by running electricity through it. But water is not a good conductor of electricity. So they add a little bit of salt to it so it will conduct electricity. So that means it's electrolyte. So decomposition means you're starting with one thing, breaking apart into multiple things. So when you decompose water, it produces hydrogen and oxygen gases. But both of those are diatomic, so you need a 2 and a 2. Remember, you cannot boil water to make this happen. Boiled water still turns into H2O just as a gas. To balance this, 2 oxygens there and only 1 here, we need to double that. 4 hydrogens, double that. So 2 molecules of water split apart into 2 molecules of H2 and 1 molecule of O2. That's a decomposition. Next one we'll do will be a single replacement. And there are a couple of single replacement types. So there's cationic single replacement, a positive element involved replacing another positive. That means a metal replacing a metal. Anionic is a negative, so a nonmetal replacing a nonmetal. First one here, magnesium reacts with zinc sulfate. So magnesium, which is not diatomic, reacts with, so that's plus, zinc sulfate, plus 2, minus 2 charge. So zinc sulfate is ZnSO4. Single replacement. This is cationic because you have a metal, positive, replacing the positive part of this. So magnesium is replacing zinc. There's my arrow. Magnesium kicks zinc out, so you have magnesium sulfate, zinc left over. This is a plus 2, minus 2 charge, so we're good there. Don't have to balance anything else out. The only way this reaction happens, by the way, is if magnesium is more reactive than zinc, which we'll get into eventually later. You guys need to write the rest of the reactions on this page. Okay, not the next page, just this page. So you've got a couple of synthesis, a couple of decomposition, okay, I think there's 1 combustion, and 2 more single replacements. So write and balance the rest of those reactions